No telescope required, no filters necessary, just a brilliant, raw cosmic spectacle. Its name is Betelgeuse, despite the similarity to the mischievous character from folklore, saying its name 3 times won't summon anything spooky. What it might summon, though, is the most dazzling light show the human race has observed in over 400 years. This red supergiant, located roughly 600 light-years away from Earth, has been acting strangely in recent times. It's been flaring, dimming, and pulsing much like a massive, dying heart flickering in the night sky. What exactly is causing this bizarre behavior? Is Betelgeuse preparing for its final, spectacular act? Today, we delve deep into the mystery surrounding one of the sky's most iconic stars, the one perched on Orion's shoulder, fated to vanish forever. Welcome to territory. This is your space. Now, let's understand what makes this celestial giant so extraordinary. Betelgeuse is approximately 600 light-years from Earth, meaning the light we see now actually left the star around 600 years ago. If it had already exploded in a supernova during that time, the light from the event would still be making its journey toward us. It's entirely possible that the explosion has already happened and we may see it at any moment, even tomorrow. When Betelgeuse finally does go supernova, it will become the brightest explosion ever witnessed by humans. But just how bright is that? Will it be visible during the daytime? Could it pose any kind of danger to life on Earth? And perhaps most intriguingly, why does Betelgeuse's recent behavior seem to contradict our existing knowledge of stellar physics? Before exploring the aftermath of such a supernova, let's rewind a bit. Our sun has burned steadily for around 4.6 billion years. By comparison, Betelgeuse is a cosmic newborn. Astronomers estimate it's only about 10 million years old. That's so young that rocky planets like Earth wouldn't even have had time to form around it, and chances are they never will, unlike our sun, which still has about 5 billion years of steady fuel ahead of it. Betelgeuse is burning out rapidly. With over 15 times the mass of our sun, it has lived fast and large. From the moment it ignited, it began consuming its fuel at a breakneck pace, even before it expanded into the red supergiant we see today. It was already radiating tens of thousands of times more energy than our sun. Now, its energy output exceeds 100,000 times that of our sun, an absolute furnace blazing in the sky. Yet, with all that power, Betelgeuse is unstable. Its erratic pulses and dimming indicate that it is nearing exhaustion when a red supergiant reaches the stage, only to fade away. The better-known outcome is the supernova. As the star's fuel runs out, its core begins fusing heavier elements, carbon, oxygen, silicon, until it reaches iron. But fusing iron doesn't release energy, it consumes it. At that point, the internal fusion engine dies, with no more outward pressure to counter gravity. The core collapses in on itself. Here's where things can go two ways. If Betelgeuse's mass falls on the lower end for red supergiants, somewhere between 10 and 15 times the mass of the sun, it will likely collapse into a neutron star and explode outward in a dramatic supernova. However, if its mass is closer to or above 20 times that of our sun, the gravitational collapse might be too extreme even for neutrons to resist. In that case, Betelgeuse may bypass the dramatic explosion entirely, collapsing straight into a black hole without a flash, without warning, just gone. Which of these destinies will Betelgeuse fulfill? Truthfully, we're still uncertain. That's partly because we haven't pinpointed its exact distance from Earth. Even small variations in distance, rotation, metallicity, or interior structure sway its final fate. In that sense, Betelgeuse is a cosmic coin toss. But if everything aligns just right, if its collapsing core hits the precise conditions needed, we could witness one of the most spectacular celestial events in human history. To appreciate how bright such an event could be, let's consider scale. Our sun emits about 3.8 x 10 watts of energy. By comparison, a supernova observed in 2015 known as ASASS and 15LH reached a peak luminosity of around 10 watts. That's the equivalent brightness of more than 500 billion suns. But we didn't see it from Earth because it occurred in a distant galaxy. Betelgeuse, by contrast, is in our cosmic neighborhood. Because of this proximity, its supernova would be breathtakingly bright, potentially even outshining Sirius, the current brightest star in our night sky. It could remain visible for weeks. But would it be dangerous? A supernova occurring within a few dozen light-years of Earth could be catastrophic, with radiation effects strong enough to threaten life. However, Betelgeuse is over 600 light-years away, well beyond the 100 light-year danger zone. So we're safe. To put that into context, if a nearby star like Alpha Centauri just over 4 light-years from Earth went supernova, it could shine as brightly as the moon and bombard Earth with harmful radiation. Fortunately, Alpha Centauri lacks the mass to go supernova. Though several visible red giants have the potential to explode, Betelgeuse remains the most compelling. That's why its recent behavior is grabbing scientists' attention. One particularly fascinating detail is its rotation. Recent measurements from the ALMA array show that Betelgeuse rotates far faster than expected, about once every 20 years. That equates to a surface rotation speed of approximately 18,000 kilometers per hour, 5 kilometers per second, much faster than Earth's rotation. This rapid spin is highly unusual for a star of Betelgeuse's size and challenges established theories of stellar evolution. Astronomers measure a star's rotation using the Doppler effect. Picture an ambulance racing toward you with its siren on. As it approaches, the pitch sounds higher due to compressed sound waves. As it moves away, the pitch lowers because the waves stretch out. This change in frequency is called Doppler shift. For Betelgeuse, one side of the star is moving toward us while the other moves away. This creates color shifts, which scientists analyze to calculate rotational speed. The findings surprise them. One theory proposes that Betelgeuse absorbed a smaller companion star at some point in its life, a process called stellar cannibalism, which could have added enough angular momentum to speed it up. Evidence supporting this idea includes the unusually high nitrogen levels in its outer layers, suggesting that inner material was recently mixed outward, possibly due to a major disruption. Scientists have run detailed simulations and now believe that Betelgeuse may have formed from a stellar collision. As Betelgeuse aged, its expanding atmosphere may have engulfed its companion. The smaller star's gravity pulled some of that outer material in, gaining mass. But eventually, it swam through so much material that friction slowed it down, dragging it closer until it may have merged or nearly did. Newer simulations indicate that the companion might still exist, orbiting within Betelgeuse's massive shell rather than having been consumed. Betelgeuse is known as a variable star. It fluctuates in brightness in a regular cycle, like a heartbeat. These cycles occur onto primary timescales, one just over a year, the other about 6 years. A recent study used computer models to explore various causes behind this pulsation, ranging from internal oscillations to magnetic field changes. But all paths seem to point to one explanation: the presence of a companion star. The team humorously dubbed it Betel Buddy. However, we may not be able to confirm this companion until Betelgeuse goes supernova. So, when will that be? Here's the mystery: no one can say for sure. Estimates place the explosion somewhere between 10,000 and 100,000 years in the future, but there's a twist. Given the distance of 600 light-years, the supernova may have already happened and we're just waiting for its light to reach us. That's the kind of cosmic uncertainty that keeps astronomers watching the sky night after night. Our own solar system, by comparison, seems calm and orderly. Occasionally, a gas giant might nudge a comet or asteroid from its orbit and send it toward the inner planets. But overall, things have been pretty stable. Still, the Milky Way contains between 200 and 400 billion stars. As our solar system travels through this sea of stars, the odds of a close encounter, though small, are never zero. About 75% of the galaxy's stars are red dwarfs, typically having 8% to 40% the mass of our Sun. The Milky Way spans about 100,000 light-years across, with a dense central bulge about 5,000 to 8,000 light-years in radius. When we calculate the odds of stars passing near our Sun, we consider stellar density, orbital patterns, and relative speeds. On average, stars move at around 20 kilometers per second relative to the Sun. Using this information, scientists estimate how often stars pass close to our solar system. The closest known encounter likely occurred at about 5,000 astronomical units, roughly 10 times the distance from the Sun to Pluto. These events are rare, happening once every few 100,000 years. Even rarer are passes within 500 astronomical units, which occur about once per billion years. So, while it's highly unlikely that a passing star would directly disrupt the orbits of planets in our solar system, such events could disturb the or cloud a distant shell of icy bodies encircling the solar system. Gravitational interactions between passing stars and the Oort cloud are ongoing, even if their effects won't be seen for millions of years.